another Systems of Inequalities word problems. Okay, so we're going to model it, we're going to write it, graph it, identify some solutions, and then determine if like a very specific combination is acceptable. Now, it has to be clear that that is the kind of the whole purpose of these types of word problems. It is possible that like for example, you know someone who's working two different jobs, but when they're working those two jobs, they can't work, 80 hours a week. That's just not, it's not reasonable. So they have to try to figure out, okay, well, how many hours can I work here for this job and that job so that I don't work more than 40 hours altogether, but I still make like a certain amount of money. And this is a real life question. And what this will tell us is that this will tell us multiple combinations that we can choose. So that's why these types of problems are just so important. So for example, it says you need to earn at least $120 per week working as both a manager at a grocery store and teaching music lessons. You earn $10 per hour at the store and $15 per hour teaching music. You are required to work at the grocery store at least 8 hours a week, but do not want to work more than 20 hours total. So there's a lot of things happening. Okay. Now in the first problem, it actually does say, it says write and graph a system of linear inequalities, and that you should have three constraints. Okay. A constraint is, for example, you have that like in the inequalities that we had, like x is less than 4, that's a constraint. Or that you have like this is less than 13 and y plus 4 is greater than 12. Like these are all constraints, things that you're going to create that are like boundaries where they can't cross. So the way that we can start doing that is, let's go ahead and just start annotating some stuff, right? So we need to earn, I'll do this color, we need to earn at least $120 per week. And you have two jobs, right? You have working at a manager and you're teaching music lessons. Okay. You earn $10, I'm going to circle this one, at the store, and you earn 15 teaching music. That's a lot of information already. You're required to work the groceries at least 8 hours per week, but you don't want to work more than 20 hours total. Yikes. Okay, so let's start a couple of things, right? Let's start working with some variables. That's usually the first thing. The variables should always represent the not just the units, but like what it is that you're talking about, and the goal that you're trying to get to. So we're talking about the number of hours that he's teaching music and working at the grocery store. So we'll say let x equals, and again, I can't just write manager, right? Like what is he doing? Are we trying, is x is the thing that you don't know. So like, do we know how much he's getting paid as manager? Yeah. Do we know how many hours he's working as manager? No. That's what we're trying to figure out. So this is going to be the number of hours as manager. Okay, and we don't have to say a grocery store. We kind of like know what that is. And let y equal the number of hours teaching music. Okay. Now, from here, okay, we have to start writing down some information. So I don't think I have enough space for that here. So I'm gonna start writing it down here. Oh, perhaps maybe I do. Okay, so we have to look for totals. Okay, so help me look for some totals. It says we need to earn at least $120 per week. So that's a total. So I'm gonna go ahead and write that here, $120 per week. Okay, and on the side here, I know that if I put $120, that entire line is gonna be about money, something pertaining to it. So at least means at minimum, or you can make $120 or more. And you have to think to yourself now, okay, he needs to make $120. How is he going to do that? By working what? And so more specifically, how much is he getting paid for each of those things? So if we know that he works as a manager, that's right, this is the number of hours as a manager, but this doesn't tell me money. This just tells me the number of hours. But we do know that how much he gets paid for working a certain number of hours. That would be $10 an hour. Just like we know that he's working a certain number of hours teaching music, but this doesn't tell us the amount of money he does. However, if we add a 20 here, this tells us that he's making $20 for a specific number of hours teaching music. If he teaches music for 10 hours, he's going to make 10 times 20, $200 just from teaching music, okay? And this is our first inequality. So that's one of the three constraints. The second thing now is we can kind of like look at this, and we did what? We did this piece. We actually took care of these things already, okay? It says that now you are required, it's mandatory, that he works at the grocery store at least 8 hours. So that is a very specific constraint. And a constraint means that now he has to work at least, so greater than or equal to 8. That's the total there, 8 or more. And the only thing that's affecting this is that he has to work at the grocery. So that's only going to be X, because X is the number of hours as manager at the grocery store. There's no reason for us to include anything about teaching music, because we're just saying that he needs to be at the store for 8 hours. But he doesn't want to work more than 20 hours total. There's another thing. So no more than, okay, does not want to work more than. So don't look at the more than and be like, oh, it's greater than. It says does not want to work more than. So less than or equal to 20. And here we're talking about hours. So where is he getting these hours from? He's getting them from the store, X, as manager, and he's getting them from teaching music. Okay, so these are our three constraints that we have here, 1, 2, and 3. Okay, now it says that we need to identify and interpret. So to do that, we need to actually graph this. What I'm going to do is first, what I like to do is I like to write down what the units are. So we see X is the number of hours as manager. I'm going to say number of hours as manager, okay, at grocery store. I'll just write grocery. And then this would then be teaching music, and I'll just write the number of hours on the top, number of hours. And to graph this, okay, let's do them here, and we'll do them in this color. Actually, we'll do it here. So we have 10x plus 20y is greater than or equal to 120. Okay, same idea for graphing. We want to get the y by itself. If there's a y there, we need to get it by itself. So we start off by subtracting 10x on both sides. Okay, and then down comes this 20y, this greater than or equal to sign. We're always going to write the negative 10x first, since these cannot be combined. And let me just see something really quick. I'm going to run out of space here, so let me just see if I can just move this over. Okay, I can't. Totally cool. Let me just write this over, okay? All right, so we get 20y is greater than or equal to negative 10x, and then plus the 120. And then finally, to get the y by itself, divide each term by 20. So this leaves us with now y, right, after these cancel out, greater than or equal to negative 1/2, right? I'm just reducing these by 10. I'm dividing the top by 10 and bottom by 10. And 120 divided by 20 is 6. So this becomes what we're going to graph, okay? Then we have the other one. I'll write this in green, okay? X is greater than or equal to 8. There's no y there, so we're actually just going to graph that. And then the last one now is x plus y is less than or equal to 20. And this one, yeah, we can totally rearrange this by subtracting x from both sides. And we get that y is less than or equal to negative x plus 20. Okay, so these are the three things that we're going to be graphing. It's going to be it's going to be messy. So we have to account for that. So here we're going to start at 6. I'm graphing this first one up here. Okay, now notice if you look at the graph that they provided, if I go up 2 units, I'm at 4. So which means that each one of these things is actually going up by 2. Okay, so we can maybe just fill in a couple of them. We don't have to fill in all of them, just a couple of them. And down here as well. So we're going up by 2s, 4, 6, 8, 10, 12, 14, 16, 18. All right, so we're starting at 6. That's here. Okay, we're going down 1, right 2. Okay, so but actually what I would like to do is it doesn't actually matter. We can actually go down 1, right 2 here, and it actually be the same thing, and that might actually work out to our benefit. So right here, now this is a greater than or equal to sign, which means that we are going to have to use a solid line. So let's go ahead and make a solid line. I'm gonna try to keep the colors the same here. So we're using purple for this, right? So let's use purple for this. Okay, and can I grab that? Perfect. And let's do this one now in blue. X is greater than or equal to 8. Now, X is greater than or equal to 8 is actually a vertical line. And it's this vertical line right here that passes through 8. So this is another solid line. So I'm gonna go ahead and just grab a different color here, solid line. Okay, just like this. And let's see if we can make this a little longer. Perfect. And the last one, I guess, that we'll do in maybe red is we're starting at 20. Okay, we're going down one, right one. So down one, right one, down one, right one. Okay, going all the way like this. Okay, perfect. Oh, I can't see myself there. All right, so then this is also going to be a solid line. Wow, a lot of solids. Going straight down just like so. Okay, take your time with it. And not like what I just did. Let's see if we can change that. Okay, I guess we're not going to change that. All right, and then just go back now and we're going to do this thing. We have to go back and we have to graph this. What is all of this? What just happened there? I don't know what this is, so just ignore that. All right, so if we were to graph this now, I'm going to try to keep it color coordinated, right? The first one was greater than, so here we go. Here's this line, okay? Where would greater than be? It would literally be everything greater than. So I'm literally doing this. Straight lines, okay? As straight as we can get them. Bam, 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 bam. Perfect. Oh, I can move myself. All right. Perfect. Then we have the blue line where we have all the x values that are greater than 8. But where would you find that? Right? All the x values greater than 8 would be going this way. Right? These are 8, 9, 10, 11, 12 going this way. So I'm going to shade to the right like this. Okay? So we can see some overlap there already happening. Then I just realized that my little thing got erased. So I'm going to have to draw my line back over here. Let me just draw this back. And for the red one now, it's less than. So we're going from here, we're going less than, which is going to be below. Okay? So I know this is going to be crazy, but do you see what the overlap is? Okay, the overlap is, maybe I can make this a little darker. Here, no, it's too dark. Okay, here is the blue overlap. Okay, here's the blue overlap. Then there was the purple coming down like this. Okay, and then there was the red coming like this. So just this little piece here is actually the overlap. And it says now we need to identify a solution. So we need to choose a coordinate in here. So because I can't see anything about what I just did, I'm literally just going to erase a little spot there. And I'm going to just choose a point. Let's choose this point. This point is 12, 4. So 12, 4. Okay. Now you can't just write a coordinate. You have to actually like talk about it. So what is the 12 is sitting in the x and the 4 is sitting in the y. X was the number of hours as manager, so it's 12 hours as manager, and then 4 hours with music teacher. Okay, and the last thing now is, so this is a combination that would work. Now there are multiple, any of these combinations would work inside there. Use your graph to determine whether 8 hours at the grocery store and 1 hour of music. So here we go, 8 hours is here, 1 hour goes there. Okay, and that's actually right down. I know it's really hard to see. Maybe if I do it this color, it's really hard to see, but it's actually right there. And you see how it's not even above this purple line? It means it wouldn't even work. It wouldn't work out. But let's see if the one that we chose would have worked out. So let's do that really quickly. I don't have that much time. So let's say 10x plus 20y is greater than or equal to 120. I'm substituting 12, 4. Okay, so 12 is the x. 20 is the y. Okay, I ran out of space there, but 120 plus 80, this is $200, is greater than or equal to 120. That's perfect. Okay, is our x, is 12 greater than 8? Absolutely. Okay, is x plus y less than or equal to 20? Let's see, 12 plus 4 is less than or equal to 20. 16 is definitely less than or equal to 20, and so this satisfies all the 3 constraints, and that is why that point is a solution, and why this point is not a solution. It's 8 hours and 1 hour of music, that's garbage. But the one that we chose, that was a perfect amount.